At this point in the module, I've already introduced you to the idea of the impulse. Here's the idea. Let's suppose that we have a mass moving with some initial velocity. A force comes and acts on the mass for a time delta t, and then after the force has acted on the mass has a new velocity v final. We say that the impulse that the force gives to the mass is equal to the force vector multiplied by the time interval for which the force was acting. Starting from this definition and using Newton's second law of motion, we can show that the impulse is equal to the mass times the change in velocity, or in other words, the impulse is equal to the mass multiplied by final velocity minus initial velocity. We're going to start this video by taking this last result a step further. We are assuming here that the mass of the object is a constant, and if the mass of the object is a constant, I can take this last equation and rewrite it by moving the mass into the delta and instead saying that the impulse is equal to the change in the product of mass times velocity. This is such a nice result that we're going to take this product of mass times velocity and we're going to give it a name. We're going to call it the momentum. Let's do this a bit more formally now. The symbol that we use for momentum is the letter P. It's a vector quantity. So we're going to define momentum, P, as the product of a mass multiplied by its velocity vector. Suppose that we have a mass moving along with velocity p. The momentum vector of the mass would point in the same direction. So now that we have taken this quantity, mass times velocity, and given it a name, the momentum, and a symbol, p vector, we can take this result here and rewrite it. We can say that the impulse given to an object is the change in the momentum of the object. This equation here is what's called the impulse-momentum relation. Let's do a very quick example to get used to the idea of the momentum. I have here a 3 kilogram mass, which is moving along the plus x direction with a velocity of 5 meters per second. We would like to find the momentum. Notice that I have dropped the vector symbols here and here because everything will be happening along a single coordinate axis, so we can keep track of direction using plus signs and minus signs. So let's write down the formula for momentum. P equals mv, and this is just a straight substitution. The mass would be 3 kilograms, then the velocity 5 meters per second. So the momentum would be 3 times 5, 15, and then the unit, kilograms times meters per second, we just leave like that. So here I've introduced you to the momentum and the formula for momentum, but we have not yet talked about why momentum is such an important quantity. In the next video, we're going to see that momentum is at the heart of one of the most important physics principles that there is, and we're going to begin using that principle to solve problems which otherwise we would have no way of solving.